Right, here's another installment of the Algebra 1 Beat the Regents Next Generation Learning Standards review book. Today we're going to look at linear regressions, and we're going to start with a sample problem before we do a couple notes. You will need access to a Desmos calculator, so if you have open up an extra tab on your Chromebook, make sure you access the testing version of that calculator. All right, so looking at our table of contents, linear regression and correlation coefficient is on, I actually think it might be 11, 12, 13, 14, somewhere page 10 is missing in there. I'm going to start on page 11, I think. So let me get to page 11. Yes, so on page 10 is a note-taking page, and we'll go back to this. But let's just go ahead and look at a question that's typical for the Regents exam and look at context clues to help us know that it is a regression question. And then what do we do in Desmos to get all of our points? All right, so this is question number 31. Here we go. The owner of an ice cream stand kept track of the number of ice cream cones that were sold each day in the first week of June. She compared the ice cream sales to the average daily temperature. The data are shown in the table below. So this is two variable statistics. We have temperature, which is one variable, and sales in dollars of ice cream. And something that's missing from this question is a visual of what's happening. So just as a quick refresher, what's happening here is that we have temp on this axis, which is the x-axis, and on the y-axis is the sales in US dollars. And there would be data points on a graph that are made by coordinate pairs. So for example, this set of data is the point 72 and then 126. And there would be a data point floating out here. And what's happening is there's a number of data points out here, and this is called a scatter plot. Now, the reason why we're not making the scatter plot is because we're going to use our technology to make an equation for the line or the linear regression line that fits the data the best. So we go down to our first of two prompts. So the first prompt, it says, state the linear regression equation for this data, rounding all values to the nearest hundredth. Okay, so first of all, linear equation. So in our head, we need to think about y equals mx plus b. And there it is. There's the x, and there's the y. Now, m is slope and b is y-intercept, and our Desmos calculator is going to give us that. Now, the thing is, Desmos is going to give us a lot of decimal places. So here it says to the nearest hundredth. Remember that hundredth means pennies, and that means it's 2 decimal places. Okay? So what we need right now is our Desmos calculator. I have one in my Google Classroom, and hopefully you could access the same one. The key to this one is it says New York version, and that means it's the one that can be used on the exam itself. All right, so the first thing we need to do is get this data into this calculator. And if you look at this, you're just like, hey, how do I do that? We have two lists. We actually want to make a table. So if you start to hit buttons here, that's not the right button. That's not the right button. But if I hit the plus sign, this is where you can say I want to add a table. The first difference is this table, it works vertically, like up to down, Well, this table reads from left to right. So our X values that we read 72, 75, 81, we put into our calculator this way. 72, enter. 85, enter. 81. I really hope I didn't mess up those numbers. I'm going to go back and check. Oh, I did. 72, 75, 81. And so that's a big idea right there. You don't want to mess up your data. Let me fix that. And so you can type in all the X values going down, and then you're going to type in all the Y values going down, and then confirm that your table matches. Let's do that now. So take a moment. I'm actually going to do a little rearranging here on my desktop so I can see two things at once. I'm going to move this to a new window, and I'm going to take this and shrink it to there, and then go back. I think this is the right one. Yes, it is. All right, and there's my table. All right, so another thing you can do is you can actually pull this up and get rid of the graph. I'll go back to that though in just a little bit, and I'm going to type my values in. So all the X's, and now I'm going to go ahead and do all the ice cream sales. All right, so there is my table. It's in, and then this is the thing that is amazing. There are two different things that are happening in this area. In this blue column, there are two different symbols. The first one is like what I drew. It says add regression. There's those data points and the line. The other thing is a zoom to the data points where they are on the graph, because right now I'm looking at just the origin, and I have the x-axis and the y-axis is really limited. So first of all, I do like to do this. I'm going to do a zoom fit, and hey, wow, just doing this quick visualization, do you see that the points are going uphill? That means my slope is going to be positive. If I were kind of to trace back, I might be able to figure out what the y-intercept is, but I really don't care because the work is going to be done for me. Now I'm going to do this where it says add regression. The default regression is a linear regression, and you'll notice that it just made a table for you, or pardon me, a graph for you. It's in the model of y tilde mx plus b, so it's not an equal sign because it's making an equation that kind of fits those points. It's just a structure. And then here it is. So notice that Desmos is giving you additional decimal places. It does give you the x, it gives you a negative, it gives you an r squared and an r. So our first command was to determine and state the linear regression equation rounded to the nearest hundredth. Let me go back to this. All right. Scroll. Okay, so you can choose to write down exactly what your calculator says first, and sometimes that's what I do because I don't want to mess up doing too many things at once. So I'm going to write y equals 15.125. Don't forget the x. Subtract 956.7676. All right. And now I'm going to do my rounding. So for rounding to the nearest hundredth, the second decimal place is where I'm going to cut off. My buddy number for this one is a 5. My buddy number here is a 7. I'm going to ignore this 8 and 6. So my final answer is y equals 15.125. Oh, that 5 means I'm going to go up. So it's not going to be 12. It's going to be 13. Don't forget your x. Minus 956. And then this 76 is going to also be bumped up to 77. All right, and then that means I can plug in a temperature and do a prediction for how much money I will make at the ice cream stand. The next part says, what is the correlation coefficient? State that to the nearest hundredth. This is a 4-point question. I don't know how I got that goofy in my head. To the nearest hundredth for the line of best fit. Okay, so the words right here, the line of best fit, that is the linear regression. So the correlation coefficient is the R, not the R squared. So you're never, ever going to use the R squared. This is a no-no. So how do I remember that it's correlation coefficient with a lowercase r? There's a bunch of lowercase r's. R is equal to, and I'm just going to write it down, 0.9863. I'm going to round to the nearest hundredth. Ignore the 3. There's a 6. Oh, it's going to not stay at 98. It's going to go up to 99. R equals 0.99. If you can do that, you can get 3 out of 4 points. The last part of the question, and so here's part 2 and here's part 3, says state what the correlation coefficient indicates about the linear fit of the data. All right, so essentially they're saying, hey, does the line fit where the points are? And that line totally did fit where the points were. So what actually is correlation coefficient? Correlation is a coefficient, is a number that's somewhere between -1 and +1. And so our correlation coefficient is right here. It's 0.99. It's so close to the 1. So basically, a negative correlation coefficient means the line is going downhill. A positive correlation coefficient means the line is going uphill. The thing that's exciting about this one, it's asking, what does it tell us about the fit? Okay, guess what? If we're near 0, we are weak. It is a poor fit. But if we are near +1 or near -1, we are strong. It is a good fit. So the correlation coefficient indicates a strong positive fit to the data. And that's all you need to say. You want to reference direction, which is positive or negative, and then you want to talk about being strong. You could be weak if you're at like a 0.5. So if I had 0.5, I might be weak. If I were at 0.7, I might be medium or moderate. Okay, so we just did a whole problem together. How can we summarize this on our notes page, the previous page, to kind of have a reference when we do a couple extra problems? So let's go back. First of all, the title page says linear regression and correlation coefficient. On your reference sheet, you will see linear equation, slope, intercept, and essentially that means form, and y equals mx plus b. It's great to see that because it helps you remind you that there's a y variable, the x variable sounds a lot the same. Essentially, okay, Here we go, linear regression. Basically, that means you're going to take a table and change it into an equation. The table, though, does not have a perfect pattern. So that means that this equation is going to be bouncing around those data points that we have. Correlation, coefficient, is a number that describes, or you could even say it scores, right, how good your equation fits. So we have to remember that it's not r squared. R squared is a no-no. And then an r that's equal to positive or -1 is perfect. And that means our dots are on the line. That's not going to happen. But if we are really close, so like r is equal to plus or minus 0.9, that is strong. If we get an r value that's plus or minus maybe 0.7, that's going to be moderate. And if we have an r that's equal to like plus or minus 0.4, it means that it's weak. And then your calculator or Desmos strategy is making a table. So remember, you have to go to plus sign, to pick table, and that table is going to be x, y going this way. So essentially, these are coordinate pairs that are the data from your table. Okay? So you're going to enter your x's, you're going to enter your y's. And then the cool thing about Desmos is it's going to give you two symbols. The first symbol looks like this, and you saw it was up near the top. It had a line like that, and that said show regression. And that gave you your equation. It also gave you, so it gave you your y equals mx plus b, and it gave you your r. The other thing that was kind of cool was the symbol at the bottom of the bar, which I think was like a magnifying glass. That's a terrible, looks like a lollipop. It's a magnifying glass like that. And what that did is it did a zoom to the graph to show you both things. It would show you the data and the regression line. And then the last thing to say about this is you need to be super careful about rounding. All right, algebra wizards, if you go to page 12, there is a second problem, number 32, and if you go to page 13, there's a third problem for you to try. You're going to try both of these or try one at a time, and then once again, check to see if your answer is right, if your rounding is right, ask your teacher for help, watch the video a second time, and this means you could squeeze 4 more points out of that Regents exam. Every point gets you closer to passing. All right, that's it for this video. Have a great day.